Alrighty, so this is going to be the rundown of Lab 9 for CVEN 303. I'll try and make it quick. This is a short lab and it's processing some LIDAR data using Python. This data was taken in US 75 in North Texas with a mobile LIDAR unit mounted on the back of a pickup. It drove through the highway and then took cross sections with the LIDAR. This is what the data looks like, and it's already available in the Canvas instance. You also have the PDF. You will need the PDF because you will need sections of code that you'll copy and run into Jupyter Notebook. If you want to use some other IED or Google Colab, that's fine, but it's recommended that you use Jupyter Notebook, the local version, not the online one, but that's entirely up to you. Submittables, you will have to submit your Jupyter Notebook file, both in the Jupyter Notebook format and also as a PDF, and also a report, a txt.report that has these sections. So let's get started. So you have to start running Jupyter Notebook. Well, download the text file with the data, start running Jupyter Notebook. This is the local version of it. And you can see here that I have created a folder, and inside that folder I have already copied the text file with the data. This is important because if you don't copy it here, you'll have to find it via commands in code. It's just easier to have the file with the data and the Jupyter Notebook in the same space, in the same folder, so you don't have to worry about having to find it later. So we're going to create a new notebook. You can see this is going to create a new untitled notebook. We're going to use Python 3 as a kernel, and then we're going to rename our notebook Lab 9. Right now I'm doing this video specifically for section 508, but it's applicable to anyone. You just have to give it a proper name. So once we save it, this is going to be the Jupyter Notebook that you have to submit as part of your submission for the lab. Now, once we have it running, Jupyter Notebook uses two different types of cells. The one that has the brackets is a code cell, and if we add another cell, I can change it to markdown cell. So these are two different types of cells. This one will run code, Python code, and this one will run different type of code like this one, which LaTeX. It's called LaTeX, as used in a lot of applications, especially maths, to get a very specific formatting that you can use. We're going to use both code and markdown cells for the whole thing. So let's get started. So just like as a quick example of what Jupyter Notebook can do, this is a Jupyter Notebook. This is running in Google Colab, but it has the same idea, and it's very useful to do equations, like I said, and also run code. At the same time, you can add markdown cells to explain, plot graphs, comments, and all of that. So it's a very powerful way to code. If you like regular IDs and run the whole code, it's also valid. Jupyter Notebook and Google Colab and cell-based coding IEDs just make it easier to create a nice product that you can show. Like I said, this is, oh, I always forget the name. I just said it. The maths language that is used for this. So it uses latex to do all of this, and it's a very powerful thing that you can use. So let's get started. So this first cell, I'm gonna make it a markdown cell because I need markdown cells first. These are gonna be the sections, and we just have to grab the whole thing, copy it, and paste it here. It will look like that, but when I run the cell, it will change to that. To edit, you just have to double click on it because my name is not my name, not that. So of course you'll use yours. And then I can run it again, and it's right. Oh, it's space. Yeah. Once it's done, we can just run it. There's a problem with formatting. Great. Okay, I'll come back to that because I don't know what happened. Should work properly. Okay, kind of worked. It should be also 2025. Please. Yeah, kind of. I don't know. It's not working great, but we'll just keep going, okay? So, the next one is going to be this text. I have to change it to a markdown cell again. Run it. This one looks okay. I don't know. Something wrong with that one. Anyhow, let's just keep going. So, next one is just going to be a title. Again, markdown cell. Run it. Load packages. And now we're going to add a code cell. So, this one needs the brackets. Great. Okay, let's pretend we did not see that last bit. Okay, so now we just have to add a new cell. This one is going to be a code cell, so it has the brackets. We don't have to change it. We're going to grab this bit, put it down. Now, Python is very powerful because it uses packages or modules. Oh, to do the processing, and you can find a lot of them on GitHub, Stack Overflow, and stuff like that. And we're going to have to import some modules. So we're going to import NumPy as alias. The alias that we give NumPy usually is np. You can give all of the modules whatever alias you want, but for NumPy, np is the one that's used the most, and is the one that is used in different packages that you have access to. So it's easier to just use np. Pandas, the agreed upon alias is pd, and pyplot is plt. So now when I run this code cell, you'll see that it runs when you have the number here. You can have a 1, whatever. It will just tell you the order in which the cells will run. If it has a number, that means the packages were loaded correctly. You might get an error. Let's see, get rid of that, run it. You might get an error like that. That means something went wrong. You can run it again. So moving on, we're gonna have a new markdown cell. So add a cell, make it markdown, run it. So we have around 6 miles, is 5.8 miles of data. It's in metric units, so they're meters. Column 3 set 3.5 represents the edge of the pavement, and set 12.644 is the approximate right of way of the data. So now in a code cell, I'm gonna grab the next section of code, close that parenthesis, okay, skipped it. You don't need the indentations, but it makes it easier to read. So I'm gonna create a data frame. DF stands for data frame. PD, we're using pandas. The command is read CSV, and then the name of the file is the file you get from Canvas. The header is the first line, the first row, and the delimiter is /t, which is tab. So that means that if we look at our data, these are all tabs that space the data. If you have a CSV, a regular CSV, you would use commas or spaces. It depends on your data. So if I run this cell, it will run, but I don't see anything. So we're going to add a new line. Going to be df.head, parentheses open close, and that is going to display the data frame that we have. So we have a column that doesn't have a name. This is the index. You can see it's bolded. This is the index. We have a num column, loc for location column, and then the columns of each one of the parts of the cross section. So each one of these rows is one cross section that we had data for, and these are the elevations of each one of the points in that cross section. So we go back up. Here is the road, and we're taking a cross section of all of this. And what are we trying to find out? We're trying to find out exactly this. There's a little ditch that runs on the side of the road, and it's there to collect rainwater and avoid uh, flooding and puddles to form on the road, because it's dangerous to drive on them and it will damage the pavement. So we're trying to see which areas of the whole highway that was surveyed have problems and have to be addressed. That's why we're processing this data. So we were here, copy that, run it. This is the data frame. It, however, has information that we don't need. For example, we don't need the index, we don't need the num column, and we're going to make location our index. And then we're going to trim the data. Like I said, we're only going to use 2 miles of data. So I'm going to grab this whole thing. No, you know what? I'm going to grab them one by one because it makes it easier. You can grab the whole thing. So this first line of code, it's going to do something specific. It's going to grab our data frame, this data frame, and it's going to drop the column num. So it's going to disappear this column, and then it's going to save it to the same data frame. So the data frame that has this column is going to disappear. So comment what we just did. We're going to drop the num column from the data frame. And then I'm going to add again df.head, so we can see the new data frame. So I run that, you can see the num column is gone from the data frame. If I run this cell again, it's going to give me an error. The reason it should give me an error is because it's trying to delete the column called num, and the column is gone. So that's why it gives me that. So I'm going to run this one again. So we have the old data frame with the whole data set. Run this again, we get that. The next line is going to be, I'm going to grab my data frame and set the index as a log column. So instead of the index being this empty column, well, no name column because it's not empty, log is going to become the new index. And you'll see that these numbers are going to be bolded. In place true is something that you have to do so that pandas saves that state for the data frame. Because if you don't, say if I get rid of that, print the data frame, it prints and it doesn't stay as the selected index for it. So if I put it back, place it true, run it, now you can see that now the new index is a log column. Next line of code. Remember, you don't have to add this df head to all of them. You can just run it once. I'm just doing it to show you what happens. Df head. Like I said, I'm not going to write all the comments. I wrote this one because it was the example, but I already told you what this section of code does, so you can add the new comment. Your comment. Same thing with this one. I'm going to run it and I'm going to get an error. Why? Because this is not a number, and what I'm trying to do is grab my data frame and then select based on the index that I set as log all the values less than meters into miles. So like I said before, these are meters, so I just have to convert 2 miles to meters. So 2 miles to meters is that number. Is that there? So again, what this bit of code is doing is from my data frame, I'm selecting just a section for which location or the index is less than a set value and then saving that the data frame and then printing it again. So now they look the same, but if I do yeah, let's just move on. They're not the same. If you print the whole thing, you can give a head a value and it will print all of the columns. So 3,000 columns, 3,000 rows. If you leave it like that, it only shows 5. So last bit of code, this. Oh, well, I already did that. Div head shows 5 rows of my data frame. We did it. We clipped the data frame. Now we need to add a new column for this, for the lowest point on each one of the cross sections. So remember, the cross section go this way, so I'm trying to look for the lowest point in each one of the cross sections. Why? Because I'm trying to see where the water is going to pool throughout each cross section, and then we'll analyze it throughout the whole ditch to see in which direction water moves and to see if we'll have problems on the road due to water. So this is the line of code. Paste it and run it. What this is going to do is it's going to add a new column called setmin, so minimum elevation, and it's going to be for each one of the rows that's y-axis is 1. Each one of the rows is going to look up, location doesn't count because it's the index, it's going to look for the minimum value of all of the columns and then store that in an extra column that's going to be created called setmin. So that's what that does. I'm going to add again df head. You don't need this bit, just to show you. And you can see setmin is a new column that has been added, and this value is the minimum of all of these ones, which is in this case here, in this case same, 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 same. So it just grabs the minimum in each one of the rows. Now we're gonna start doing some plots. Gonna grab that. This is gonna be a markdown cell. Run it. Plot section. So this is what we're gonna do. We're gonna plot the profile of the edge of the pavement and the lowest point on each one of these cross sections. So the code is this. It should look something like that, but let's see how I can make it. If I run this, it's gonna have an error because it doesn't know what question mark is. So we're gonna give it a figure size. 10 by 5 is good. You can use whatever you want, but 10 by 5 is good. Font size 10 is good as well. For this case, everything 10. So what this whole section is gonna do is gonna grab a pie plot, create a figure with this size, and then plot two things. So this is gonna grab the column called set 3.5 from idea. So this one, which is the edge of the pavement, and it's gonna plot it as a line, and then it's gonna grab set min and plot it as a line 2. We're gonna add some labels, legends and texts, location or stations. So this is called location. We're not doing stationing, so we should get rid of that and just leave locations. Now we're gonna run it, and that is gonna be our trimmed data set. If you don't trim the data, it just keeps going and looks slightly weird. Let's see if I can show. So I'll run that, get rid of num, select log. I will not do this bit again. Create set min and then plot. So it will look like that. So that's why we're trimming it here, because we want information about this area. Why? Because all of this has higher elevation, so all the water is going to flow this way, and then this is the area that's going to have problems where the elevation stops going down, and there's low points, high points, low points, so this is going to be a big problem area for a highway, because all of the water that's running on the ditch is going to pool here and it won't be able to escape, and it might go into the road. So that can happen. I'm gonna run everything. It runs and looks like that. So what does it means when the orange line touches the blue one, like here, or they get really close, they're the same, they're the same. That means that the lowest point in the cross section, in this cross section, the lowest point is the edge of the pavement, right? So that means that any water that falls on the road is not going to have anywhere to go because the terrain goes up in elevation at the edge of the pavement, and the water that falls as rain on the right of way is also going to pool. So all of these areas are going to be problem areas where ponding is going to happen on the road. You don't have to worry about this. It's just an output from Jupyter Notebook, and it might look different in yours. So that's our fast figure. You're going to have to write a report about this. So you're going to right click the figure and you should be able to save it. Although I cannot do it here, and I don't know why. Anyhow, you can also do a screenshot of it to save it because you're going to need it in your report. So next plot we're going to do, I'm going to grab the whole code and it tells you what we're going to do. Top view of the ditch flow line as the offset from the edge of the pavement. So I'll copy that bit and then give it values for tick size, that font size 10.2, figure 10 by 5 should be okay again. I'm gonna run it first and then, well, I'll explain what each one of the lines do. So I can take this bit, another cell, so we only have to run this once. Add another cell here, move it up. So you don't need these extra cells. I'm just putting them down to show you. So df head. So run that. That's our data frame. And this line is going to create a new column called FL flow line. So the ditch flow line, so the center line of our ditch. And what this line of code is doing is going row by row, looking for the minimum, and then instead of grabbing the value like this one just grabs the minimum value per row and adds it to setmin. This one, what it's doing is it locates the minimum of a row and then looks at the column that holds that value, but this is not a number and I need the numbers in order to be able to plot them. So what this bit is doing is grabbing this string, extracting just the number because it's separated by the space, and then saving it as a float in the column called flow line, FL. I run this bit and then this bit. You can see we have a new column called flow line, and instead of having the elevation, the minimum elevation, it has the value of the column, but it doesn't have the set, it has just a number. So now I can plot the data frame and it will look something like that. And yeah, that's how it's supposed to look like. Let's give it maybe a 50. Yeah, kind of. It looks clearer. So down here, you don't have to do this. It's just to show you. I don't know how to do the next limb. Anyhow, so down here in 3.5, which is the edge of the pavement, you can see the areas where the flow line, the lowest point on each one of the rows is actually the edge of the pavement. And these ones match the areas where these lines touch, right? So those are going to be the problem areas that we have. The farthest away from the edge of the pavement or from 3.5, the better, because that means that the water can flow away from the road. So that's our second plot. And then the location of the first ditch low point is also important. It's going to be that because that means all the water that's coming from this direction when it rains and all of the water that's coming from this direction is going to pool here, and it's going to be, even though they're far away, is going to be maybe a problem area. We just need to make sure that it's not. And how do we do that? Well, we use this graph and we can see 3.5 is up here, and this is the end of the right of way. And even though this is lowest point and could be a problem location, we can see that the water has a direction to go away from the road. This is missing the title, so plot.title, because we're extracting the location that has this lowest point. So it's gonna be location, maybe set, no, location. You don't have to do this bit. It's just it will look better. So location, space meters. Right. Yes. So at that location, that like I said is around there, is the first low point, but it should be okay because the water has a direction to leave the ditch, so it's gonna be fine. And that's that. Uh, those are the three plots we're gonna use. That you're gonna produce from the data, and from them you can conclude some things. There's a lot of areas that might be problematic uh, for flooding of the road when it rains, and you can identify them from this graph and the other graph. And even though this is the lowest point and most of the water would pool, it has a clear direction in which it can leave away from the road. So that's kind of the conclusion of that. So you're going to submit your Jupyter notebook. So this file, also a PDF of it, because sometimes Canvas doesn't play well with Jupyter notebooks. To do that, you're going to go to File, Save and Export as a PDF. And if this happens to you, it means you're missing something on Anaconda on your kernel. The way around that is going to be the same. Notebook as HTML. That's going to download it as a file, as an HTML file, and then you can print this and save this as a PDF, and it will have everything. So that's the way around this, the missing bit, the module that's missing. So you'll do those two, and then you're gonna write tx.style report. It only needs these sections. You already have a template that has more sections. You can use that and get rid of the sections you're not gonna use, or you can create your own. It doesn't matter. So remember, you're trying to explain to me that I don't know anything about any of this, what your information means, what your graphs mean, and all of that. And then in results is where you're going to put down your plots, but not just pop them down, explain stuff about them, because I already told you, like, this is what does the places where they touch mean, same this, and this last graph, that means that even though this is the lowest point, the water is going to run away from the road instead of into the road. And then conclusions about what you would suggest as a course of action in this highway. So 3 submittables. And that's that. That's lab 9. Thank you for sticking around. I'll see you guys later.